Good day. Today I'm here with my navigator Lindo. Hello, Lindo.
Hi everyone, I'll be the navigator of today's session.
Okay, cool. So today we're discussing Java chapter 12, lambdas and streams. Let's jump into it. So what is a lambda? Lambda is like a short way to write a method, basically. So it's a shorter way to declare a method, and that's why we call it an anonymous function. So for instance, over here you see this method add1, which has a parameter x and then returns x plus 1. So you can always write a shorter version of that. That's why we call it a lambda expression. So you have here x as a parameter with this arrow, which represents basically what's going to be returned after that, which is x plus 1, and then whatever is printed from there gets printed. Then going hand in hand with lambda expressions, we use a functional interface. So basically, a functional interface is an interface with exactly one abstract method. So each functional interface has one abstract method that needs to be implemented. So there's different types of functional interfaces. So the first one here is this one, function. It takes an input and it basically gives an output as well, and it returns any type. And in order to call this functional interface, we use the apply method, basically. So to show how that works in my code, here I have this class lambda playground. So firstly, here I have declared my functional interface over here, function, and you can see here what it takes in an integer and it returns an integer, and it declares a variable named doubler, and then within it, this is where we declare the lambda expression. So the parameter and then x times 2. So whatever gets passed to this is going to be multiplied with 2. And basically over here is where we call this expression using doubler.apply, and then we pass this argument 5 to x, and when you print it you get this final result. 5 doubled is 10. So mainly with this functional interface is that it takes an input and it returns an output. Then we have basically another one named consumer. Consumer basically takes an input but it doesn't give an output. So because it doesn't give an output, then the return type is void, basically. So let's see how that works. So over here I declared this functional interface, consumer, and the name of the variable greeter, and within it this lambda expression here. Basically, because it's a consumer, it's just gonna take in a value that we pass here when we call this accept method. So this name gets passed to name, and then when we print it out, then it shows hello Tom over here. Anything else to ask or add, Lindo, so far?
No, it's pretty good.
Alright.
It's pretty good.
Okay, cool. So yeah, this basically is just taking in an input, essentially. Then we have over here predicate. This functional interface, it takes in an input and gives an output, but the difference is it returns a boolean value. So it's basically just gonna test a condition whether it's true or false, essentially. And based off that, it returns a boolean value. And we call it with this test method. So here declared the predicate functional interface, and you can see it takes in its value over there, an integer, and this variable within it, there's the expression. So here I'm just basically checking if the number that is passed to n is an even or an odd number. So in order to call this expression over here, we use this reference variable as even, and then we call the test method and pass the value as an argument over there. Then it uses this calculation to check if it's odd or even, and in this case you can see it's an even number. But if we pass an odd number over here and we call the test method, the value gets passed to n, and then it returns the Boolean value, because we're using a predicate interface. It returns false. So then after that, basically we have the supplier interface as well. So let's see what it is. So this interface basically is just taking in an input. No, it doesn't take in an input, but it basically gives an output. So it's applying an output. And it returns any type, no specific data type it returns. And we call it with this get method. So basically here I have this array quotes, and it has different strings or different quotes over here. Then I'm using this random object here to basically use it to choose a random quote from my array. Then I declare the supplier functional interface over here, and within this, so as I said, it basically only gives an output, so it returns an output, and within the quote supplier variable, I have my lambda expression here. So because supplier is only giving an output, it doesn't take, there isn't any parameter declared essentially, because it's not taking in any arguments or any values, it just returns values. Then basically following this arrow here, we have basically just using the random object to generate or find a random quote from my array. And when we do that, print this out, and we call quote supplier.get, and then it's basically gonna get a specific quote from here and return that quote, as we can see here. Then there's this runnable interface as well. So with this one, it doesn't take an input and an output and returns void. So it's just to run a method that prints a specific string. So it's similar to just writing, like just printing a string. That's it. So here I just declared a for loop that is basically just gonna make a countdown over here, 3, 2, 1, and then that's it. So that's with functional interfaces. Is anything to add there, Lindo? Anything
Nope, nothing to add actually. I just want to say, please push that folder of functional interfaces on your GitHub so I can also see it on my side.
Oh, it's not there. Okay, I'll do that.
No.
Okay, I'll do that. Excuse me. I'll push it after. So yeah, that's basically with functional interfaces and like how lambda expressions work hand in hand with that. So then lastly, I'm gonna talk about streams, right? So I remember we were busy asking questions about streams. You know, I still don't know how to define a stream exactly, Lindo. So like, is it like...
Yeah, well...
Yeah.
I don't know like also how to define it, but I know how to use a stream.
Yeah.
So basically when you want to manipulate a list, right? But you want to keep the original list. So I don't know if like I'm making sense. Let's say like you have a list of let's say different coffees and you want to manipulate that list maybe. So this is used because usually we're dealing with data sets that we don't want to change, but we want to get certain thing from it. Remember how we used to do on SQL, right? Let's say you have like a normal table of data and you want to get like distinct results. You want to get like certain results from that table and not everything. So Stream is something like that. You can have like distinct results. You can filter based on what you want. You can even like give it a limit. The same way that you did with SQL database, basically.
Okay. So streams comes with like
Yeah.
it comes with all those like methods like filter, sorted, and all of that.
Yes. Yeah.
But then it's like in a way using a temporary list to manipulate that data and stuff.
Yeah.
But you're not changing the main
Yeah. It's
list.
temporary.
Okay.
Yep.
I see.
That's basically the whole idea of streams.
Okay.
You see, even when like you get like distinct results on like an SQL database, you say like select all from and you'd like that's what you're doing. You're not changing the original table. You're just like getting certain results from that table.
Oh, yeah, it works the same with SQL.
Yeah.
Like, okay, no, I
Exactly.
see. When you make reference to that, that makes sense. Yeah, you're not actually changing the table.
Yes.
Like, yeah.
You're not changing the table. You're not manipulating a list in this case. You're not doing anything to the list. You're just getting the result that you want.
Okay. Okay, makes
That's
sense.
all.
That makes more sense. Yeah. Alright, cool. So, yeah, basically, I have. This is where I'm using Stream to process my data. So, firstly, I've declared a list over here named words, and it's just gonna show a list of words over here. So 5 different words, and then here I have a different list named results. So within it, this is where I change. Well, this is where I create my stream using this words list. So I say words.stream, right? So as we were saying, in a way, it's like a temporary list so that we can get specific data that we want from that list, but without changing the actual list over here. So after creating a stream, I can use different methods or different operations that go along with that stream, right? So essentially here I'm using this filter method. This is just gonna in this case it's gonna keep words longer than 4. So I'm filtering all words out that are not longer than 4 basically. And we do that with this length method to check the length of the words there and get words longer than 4. Then using this, wait, let me run this to show that it works. So yeah, basically after that I'm using map. So with map I can change or manipulate the data. Here I'm gonna basically change the strings to uppercase essentially. So as you can see here, the strings were changed to uppercase. You can only do that using this map operation. Then I have the sorted method. Sorted is used to sort the words alphabetically, but you can also use sorted for other stuff, like if you want to use like a reverse method to reverse all of this, if you want to sort it in any other way, descending or ascending order, you use sorted. In this case, automatic by default it sorts the list in alphabetical order. Then using limit over here, as you can see I have 3 words. I'm just using limit to limit it to 3 words, and then it's just gonna show the 3 first words in alphabetical order essentially. Then using collect, collectors to list is basically gonna, does it change it back to a list? What do you think, Lindo?
It prints it as a list.
Prints
That's
it.
what it does. Just
Okay.
prints the stream like a list now.
So
So it returns all those results, and now it stores it to a list, but not a list that is same as the list collection, like the normal usual array that you know,
yeah.
like square brackets, the one that you know. Yeah.
Okay. Makes sense.
Mhm.
Oh, because you can't print it as a
Yes.
stream, right?
Not quite sure, but I
Okay.
think you can. Okay, but okay, I
but
think
a
you can
stream.
because remember, the
Yeah.
original results are a string. Like the original list is a string. Okay,
But
let's try it actually.
you see why I say
Like
that?
comment
Because
that line out.
you try this
Yeah,
one now.
yeah. And let's
So
see. Without using the dot collect, what can you do? And then like will it print the same results? Let's see. I'm curious also.
what is going on?
What is this? Oh, you need to put on the semicolon here.
Yeah, but limit now. It's weird.
Let's see. Why is it doing like this? Going to throw in some error. Incompatible types. Okay, but I don't understand. What are we forgetting?
You know
Are you
what I'm
forgetting
thinking?
maybe
Yeah.
mhm.
Like I don't
Let
know.
me
I
see
thought this
example.
changes it to
Yeah.
a list. I thought it changes. I thought collectors.toList changes it to a list in order for it to be printed. But I don't know why we're getting this error. Let's see.
Let's see. I want to go through some of the examples that I did. And funny, all of them seem to be ending with the dot collect method. Collectors dot to list. I don't see one that ends without the dot collect. Let's put this
I
into
think I know
ChatGPT
why.
actually.
Wait, let's
Yeah.
well, why is this is uncommented now? Oh, that's because it's because we uncommented collectors. No, it's fine. Yeah, we put it in AI and see.
Okay.
I wanna ask why. What happens when you comment out collect?
Why is your ChatGPT looking like that?
Look how.
I don't know. It's different.
Show me yours then. I'll see.
Like you see at the corner, you have something written AIP RAM. And then that dashboard that you showed before, like it looks different. What is that? What is AI? What's this AI
Oh, here.
RAM? Oh, what's that?
Not sure.
Okay.
Really not
Yeah,
sure.
click on that.
But yeah. So when you comment
Okay,
out
when you
collect, this line will not compile. Yeah. The method stream.
Why?
The method stream creates stream string. All the operations filter map are intermediate operations that return another stream. The method collectors is a terminal operation. It ends the stream. Oh, this ends the stream and then produces a list.
Okay.
So like, it stops the stream because it isn't like a stream, it's like a pipeline. I remember you guys were saying that
Yeah.
when you were describing it to me. So it's like a pipeline.
Mm-hmm.
You have to end it, and then after that, in order to print the results from the stream, it's sort of like you're converting it to, or it's like producing a list. So you can print out that newly created stream or list, if that makes sense.
Okay, but the question is, why can you not print a stream? Like, why can't we see a stream?
Yeah, true. see.
Stream is not a data container like a list or an array. It's a pipeline of operations, a sequence of elements that are produced on demand. Okay? Think of it like a water pipe. The data flows through filters and maps, but unless you open the tab using a terminal operation like collect for each account, nothing actually flows. That's why we say streams are lazy. They don't do anything until you tell them how to end. Okay. Okay. So I guess like the whole point of a stream basically is to just manipulate the data.
Yeah,
That's all. And summary hold the data.
I actually understand it better now. But you were right in saying like it's kind of similar to in a way SQL, like because I see this limit method and all of that.
Yeah.
So
You move that semicolon.
interesting. So yeah.
Okay.
So yeah, then you print the result. So result is gonna store all the like what we get after all these operations run, and then when we print that, it shows basically the result as we saw there. So yeah. Alright, cool.
Okay, we still have a lot of things to learn actually. When you're doing those videos, you realize that there's a lot of things you need to cover.
Very true, yeah.
But yeah.
We'll get there.